Our guest speaker is Ken Cukier. He is the data editor of The Economist and co-author of the book Big Data. Welcome.
Thank you very much, Becca. Okay, good morning. Hey, good morning. Big data is a big, big topic. In fact, I bet if I tried to ask someone here to define it, you probably couldn't. In fact, show of hands, who here would be willing to define big data? Raise your hand. Aha. What a wise audience. You never told me. So, developers, that's what it is. I'm sure your managers, the suits would have given you lots of definitions. But the people at the coalface, the people right in front of where the software, the code, and where the data gets collected know better. Right? The term big data has just cropped up, it's mushroomed in the press, and there's really no good understanding of what it means, and it seems like actually a lot of it is just BS. Well, what I wanted to do is come here to Berlin and tell you that in fact it's not. That big data is very important. It's going to be the future of all of business, and in particular business strategy. And to explain to you what big data is and why it matters, I want to start with a story. It's the story of a company, and the company is called Faircast. So several years ago, a computer scientist in the United States named Oren Etzioni had to go on an airplane from where he worked at the University of Washington to Los Angeles, where his brother was having a wedding. And he did what we all know to do. If you buy your ticket long in advance, prior to the date of departure, you save money. So months before the wedding, it's a wedding, he knows when the date's going to be. He buys his ticket, and the day of departure comes. He gets onto the airplane. He's now 30,000 feet into the air, and he asks the person sitting next to him, how much did you pay? And the person says that he paid considerably less, even though he bought the ticket just a few days before. Oren Etzioni's upset. He asks the next person, and the next, and the next, until there's a small buzz in the back of the plane as the nutty professor is asking everyone how much they paid, right? And of course, everyone loves it. We're all disclosing, they are all disclosing how much they have paid because it's sort of price transparency, which is rare to get. We know that when we're crammed in between the middle seat, that every single seat in economy is a pure commodity. No one is different than any other. But at the same time, we all know that we all paid a different price for it. So the difference between computer scientists and the rest of us is that normal people, when they land, they put their seat back up in the tray in the upright position, they leave their worries behind and they get on with life. Not computer scientists. He has now sketched out a methodology. And the methodology is just to do a souped-up version of what he has done in the plane, but online. He's going to scrape some data from the internet to find out prices and dates of departure for airlines, and then make a prediction whether the price is going to go up or go down. Empowers consumers. It tells you whether to wait or to buy, right? He calls the research program Hamlet. To buy or not to buy? That is the question. Okay. And so he gets some venture capital funding, and so finally Faircast is now airborne, and it's making lots of money. It's saving passengers, at least $75 per trip, because it tells people whether they should buy the ticket right away, the price is likely to go up based on historical patterns, or they should hold off and wait, because the price is probably going to go down. Okay? Microsoft likes the company. In 2009, actually a little bit later, buys the company, 2011, buys the company for over $100 million. A lot of money. But here's the deal. At that time, Faircast was crunching 75 billion flight price records with which to make its predictions, which represents basically every single flight and every single seat on every single flight, for every single route, for all of American commercial aviation for an entire year. This is something that was unthinkable even a decade before, and now it was being done by a startup. And here's the other thing. You just know that when they created electronic passenger records in the 1960s, never for a second did those companies think that their own data could be used against them to undercut their business model. So what's happening here? What's going on? There's a lot of features to the story. The first one is technology. We can do things that we never could before. The second is data. We have data that we didn't have before, so we can learn from it. The data has a value, and we can tap it. And the third is mindset. Oren Etzioni had a big data mindset. He understood that if he had the technical competence and the humility, he could interact with that data and extract a new form of economic value from it. It is in that respect that the data is a resource. It is a new raw material of business. It is a vital economic input. Traditionally in economics, we used to think of the three factors of production as land, labor, and capital. And it is easy to understand why in the mid-1700s, why the classical economists didn't add information to the mix. Because it was just so hard to collect the data, to store it, and to analyze it. And today, almost all of those constraints have almost entirely gone away. And so we have the big data era. So what is big data? Well, the term meant something when it was coined in its modern version about a decade ago. At the time, Moore's law had just hit another increment, and companies were getting swamped by information more than ever before. It was largely places like in Silicon Valley, search engine companies, Google and Yahoo. And in the East Coast of the United States, it was genomic research centers like the Broad Institute at Harvard and MIT who were doing sequencing. In the case of Google, around 2002, 2003, 2004, the information was so vast that it exceeded the ability of the infrastructure to handle it and to analyze it, so that researchers had to innovate at the layer of software and hardware just to run their analyses. From that period, we saw innovations like MapReduce and Hadoop, the open source variant of it. Right? At the same time, an area of artificial intelligence, machine learning, which worked a little bit but not very well, started to get a lot of promising findings, not because we sped up the algorithms or we had cheaper storage, but simply because we added more data. Okay. Now, today, the term has certainly become diluted as journalists like myself and others use it with wild abandon, and it's devoid of some of its meaning. But if we wanted to give it some meaning, let's start with this. Big data is the idea that there are things we can do with a large body of data that we simply cannot do when we're working with smaller amounts. That the change in scale leads to a change in state. That a quantitative shift leads to a qualitative shift. Or if you like, more isn't just more. More is different. So what does more look like? More looks like this. You can see that in the year 2000, we like to think that we are interacting with the information society. We were doing so in name only. Even back then, the amount of stored data grossly exceeded the amount of analog data, absolutely exceeded the amount of digital data. By 2002, it was parity. The reason why, analog data, which is still growing, right? Things like books, Post-it notes, museum pieces, tableaus on canvas, it grows linearly. Digital information obviously grows exponentially, and so whoosh. Now, the amount of stored information in the world doubles roughly every 2 or 3 years, so you can see that by the year 2010, the purple part would be twice as long, so almost to the bottom. The pink part at top would be half. By 2013, we're now through the floor, and we're through the ceiling as well, and we don't see anything that's going to stop it. You can take just one area and look at how data has changed it, and look at the magnitude of these changes. Now, this is an extreme version in genomics, but it's still useful to think about. Around the year 2000, 20 nations in the world announced that they had finally sequenced the full human genome. It took them about a decade, and it cost about $1 billion. Today, a single genomics facility can sequence the human genome in about a day for about $1,000. Now think about what these changes mean. Okay? This is huge. Again, it's a stream example, but it tells us a couple things. The first one is how we treat disease is going to completely change. Instead of creating drugs for the average man, a fiction that doesn't really exist, we're going to be creating drugs that's tailored to your genetic makeup and your genetic makeup. And how we regulate that, we don't really know yet. It's not really certain, because the regulation's going to have to change. We've not actually tried this before. The second thing it tells us is that genomics is not alone. Right? Every industry is more swamped with data than ever before, whether you're in media, whether you're in retailing, manufacturing, automotive. There's more information being created all the time that we can extract signals from and turn into a new form of value. And all you have to do is think and cast your imagination a little bit further ahead and imagine what will happen in another 15 years. What will the world look like then? Right? Will we have the 1-second genome? Right? Will it cost $1, or am I off by 2 orders of magnitude and it'll cost a penny? And we saw a huge flourishing of creativity in the 1800s in Britain when they introduced the penny post, so that people could send letters multiple times during the day. What happens when we have the penny genome? What sort of assumptions change then? So how does this all work? What's happening? Well, there's lots of different technologies around big data, and the one I'd like to take a moment to think about is the area of machine learning, which I mentioned already. Okay. Machine learning is a branch of artificial intelligence, which is a part of computer science, but it really owes its lineage to the mathematics department. And the good way to understand what machine learning is to understand it from its very origins, how it was created. And behind me is Arthur Samuel, and he's a computer scientist at IBM, and it's in the 1950s, the early 1950s. And what do you do if you are a computer scientist at IBM in the 1950s and you like to play checkers, but you write a computer program to play the machine in checkers? And so that's exactly what Arthur Samuel does. And he writes the program, and he plays the machine, and he wins. And he plays the machine, and he wins. Plays the machine, he wins again. Because the machine only knows what a legal move is. Arthur Samuel knows something else. Arthur Samuel knows strategy. So he writes a small subprogram alongside the operating program that does one simple thing. It calculates the probability that after every board configuration change, every move, that a board is likely going to lead to a winning board versus a losing board. A simple probability table, continually updated. Plays the machine again, he wins. Plays the machine, he wins. And then he leaves the machine to play itself. It plays itself, it collects more data. It collects more data, it increases the accuracy of its predictions. And then he goes back to the machine and he plays it, and he loses. And he plays it, and he loses. And Arthur Samuel has created a machine that exceeds his abilities in a task that he taught it. And this idea of machine learning is going everywhere. So if I were to try to Google the name of the CEO of the cute company, and I misspell it, I leave out the final S, how did Google know? Who at Google programmed the computer to say, no, Juha's last name is with an S? No, of course, no one did that. It's a machine learning algorithm. The system knew to look for instantiations of these two names, of these two words, Juha and Verilius, and they could see that the instantiations of the last name with an S were much higher than one without an S, so it makes a presumption, it presumes that in fact I'm looking for this one person, and it discloses to me, in fact, that it's actually telling me not what I asked for, but what it thinks is correct, and it does this all the time. It was a machine learning algorithm. It was programmed to do it that way. It had to infer what I wanted. It didn't know at the outset what it was going to be. It's very simple, right? Bayesianism. Machine learning algorithms is the basis of why computer translation is not so laughable anymore, why speech recognition is starting to work. Self-driving cars is a machine learning algorithm. Some interesting research came out about 2 or 3 years ago from Stanford University. The researchers, using machine vision, took cancer cells that were either highly or very little cancerous, and they ran it through an algorithm to see if the machine could detect which ones were going to be highly cancerous or not, and the traits that would best predict whether a given cell sample was going to be cancerous. And sure enough, the machine learning algorithm was able to do that better than a human being could. In fact, it spotted the 12 telltale signs that best predict cancer. The problem, the medical literature only knew 9 of them. 3 of the things were ones that human beings didn't know to look for, but the computer could spot in a large body of data. So if you are a pathologist, you might want to rethink how you bring value to what you do, because the algorithm will work better than you do. And if you're a developer, you might want to think about how you can collect data and turn it into action, because that is going to be the new source of competitivity. Now, this example is about hospitals and the treatment of people in it, and so as far as it's about hospitals, it's also about humans. But I want to suggest to you that this is not about hospitals, and it is not about humans. It's about something else. It's about looking at the world in an entirely new way, about thinking about everything that happens and everything that goes on as a way in which we can collect data and learn from it. The world as a platform for the collection and the analysis of data. Now, one reason why we have so much data in the world today is because we are collecting more on things we've always collected it on. But another reason why is we're taking things that have always been informational and rendering it into a data format. We're datafying it, so to speak. So you can think of the idea of location. Where is one person or another? It is a matter of information where someone is, but it's not necessarily a matter of data. So take the example of, Stradivari. In the 16th century, if I wanted to know where Antonio Stradivari was, right, I'd have to follow him around, I'd have my sundial, I'd have a little fountain pen, a quill, and I'd write Stradivari is in his studio, right? Hard problem, not going to happen. Now think of it today. We know that somewhere in the world there is a database that has our location data in it for every single second of the day, going back at least a decade. Now, the database is probably in Langley, Virginia, but nevertheless, the point is that location has become a matter of data. Okay. Or now think about posture. The way that you're all sitting, whether you have sittings, that Catherine's sitting, the way that you're sitting, it's all different. And it's a function of your leg and your back and the contours of your back and your weight and the distribution of your weight. And if I throw 100 sensors into your chairs right now, I can create an index that's fairly unique to you, sort of like a fingerprint. What could I do with this? Well, researchers in Tokyo are using it as a potential anti-theft device in cars. The idea is that a carjacker jumps behind the wheel, tries to stream off, and the car recognizes that a non-approved driver is behind the wheel, and maybe the engine conks out, unless the person types in a password into the dashboard. If you're the parent of a teenager, maybe you can think of another use of this wise technology. The point here is that when we datafy things, we can store the data, share the data, process it, and use it to extract new forms of economic value. So what is the value of data? Well, in the past, the value of the data was the primary purpose for which it was collected. But in the age of big data, the value shifts to all the myriad secondary uses for which the information can be put. Think about Walmart. It collects its transactions, its receipts, and it does so for bookkeeping. Years ago, it compared its transaction data along with weather data, and it spotted that whenever there was a storm approaching America's Northeast, not only would sales of storm supplies like flashlights and batteries increase, but so would sales of Pop-Tarts, the sugary American breakfast snack, not food. Now, we don't know, said like a parent, huh? Exactly. We don't know why this is the case. It's simply a correlation, but it's good enough. Walmart was able to know that whenever there was a storm approaching, not only would they put the storm supplies, like the flashlights and batteries, at the front of the store, so too the Pop-Tarts, so that they can increase convenience for customers and also increase sales. The value of the data was in the reuse of the data. The data, in this respect, was a corporate asset. But it's not like this asset comes about naturally. You have to build it in. You need the data by design. It doesn't simply happen. It's the intentional decision to build into the code, the ability to collect the data, and then to have it and to store it of all the different interactions, and then to be able to analyze it, is one that needs to be built into the system. So it's incumbent on developers to realize that their job is paramount as a matter of corporate strategy and corporate excellence to extract value from the system as it's being run for the purpose by which it was built, and all the secondary purposes and ways the data can create new value around that product. It's about building it in. And then you can think, more broadly, what will the future look like? What will happen when every product has a computer chip in it? When every product is connected? Will every soda can have a GPS on it so we know where it's drunk? Will it have a sensor so it can identify my biochemistry? I have no idea. But these are the sorts of things that we need to think about. And when we do, we can see that a lot of things that we take for granted may indeed change. Will everything that is a good become a service, and we can change the revenue model around it to recurring revenue rather than a one-time sale? Will the power and the equilibrium that exists between suppliers, distributors, and manufacturers, which is never easy but always finds some sort of parity, will that shift again, and will the value actually go to consumers? Will the power shift there too? We don't know. But these are the things that we need to think about, because by adding data to everything that we do, it changes things. And most importantly, it changes the people in the organization. What you need to know to do well changes. Who you need to know to do well changes. Who you need to partner with, who your rivals are, change. And a lot of assumptions that we take for granted today that we don't even see because it's part of the background are open for question. Think about it. If we have self-driving cars, will we still need windshield wipers? Everything that we do in society is a function of the information constraints and liquidity around us. And when we change the idea of liquidity and we change that friction, a lot of these things are open for question. In the dawn of the web, it looked like the value went to the startup, those unencumbered with the thinking of yesteryear, because they could do things afresh. Their models were fresh. But if you think about it, in the world of big data, the advantage goes to the incumbent. It goes to the modern player. And the reason why is that they have the data. Of course, they have to do something with it. They have to use it. In this world, access to data is paramount. Now, of course, there can be too much access to data. The world of big data has risks as well. Okay? And among those risks are privacy. Okay? Privacy has been a problem in a small data era, and it's going to remain a big problem in the big data era as well. I don't think we're ever going to fix the problem of privacy. We're always going to have to try to manage the problem of privacy, and every generation will have to work afresh to see that they can do so according to their values, because those values themselves change. The next risk is the idea of propensity. We will have algorithms that will be predicting what we are likely to do, and we may be held accountable before we've actually acted. So in the world of big data, we may need to render sacrosanct the idea of free will and human volition, just as we tried to do that in the judicial system with administrative fairness in the 20th century. The idea of pre-crime is a very real one. If a police officer knows that this person has a 95% likelihood of committing a felony, he will be bound to act. If not, he's being anti-science. But the person can simply say, if you arrest me prior to, or take any decision against me prior to me acting, you're taking away my moral agency. And that would be a debate that we're going to need to have. Likewise is the question of ownership. Who owns all this data anyway? The entity that collected it, or the person from whom it was taken? Just this week and next week, the European Union and the United States look like they're going to head into a diplomatic squabble over the issue of safe harbor and how data is stored and who it belongs to. Critical issues for developers and for business people. And finally, and maybe most importantly, and there's no good term for this, it's the idea of dataism. That we may endow with this data a sort of mystical black magic and trust it a little too much. We must remember that the technology and data is a servant, and we are its master. That the data is only a simulacrum of reality, not the real thing, just as a map is not territory. And while we need to embrace big data, we also need to be careful that we don't do so at the expense of our values, our human judgment, and our common sense. So what will the future bring? Well, in the past, it took a deliberate action to measure and to quantify. In the future, everything is going to be quantified. Everything will be enumerated, and everything will be measured. I think the benefits outweigh the drawbacks. I look forward to seeing what happens. Thanks a lot.